Hello there and then welcome to a brand new video. This is Hub Beyond Numbers where we learn maths the easy way. Now in this lesson we are looking at some past questions on numbers and then numerals. I'll try my best to be very simple and then straightforward. If there's anything you need clarification on, you can always visit the beginning of the playlist where I have done a tutorial, an insight tutorial into all that we'll be applying in these set of questions. So without much ado, let's quickly look into it. For the first question here, we have to find the lowest common multiple of 9, 8, and 16. Now, our solution. Realize that there are two methods we can use. For now, we know of two methods. One is just listing out the multiples of all these numbers. And then you now come and look for their common multiples. And then among that, you look for the lowest among all of them. But there's another one also that has to do with prime factorization. And that is what I'll be doing in this lesson. So if we take 9, for instance, we want to write 9 as a product of prime factors. Among our prime numbers, let's look for numbers that are factors of 9. So to write out our prime numbers, which I want to do over here, we have 2, 3, 5, and then 7. You see, so among this, which is a factor of 9, we can see 3 over there, and 3 times 3 gives us a 9. And we said anytime you have prime factors, you are not going to form any branch again. So we come to the next number, which is an 8. So we have 8, and we want to write it also as product of prime. So for the 8, the smallest prime number here, which is 2, divides it exactly. So we have 2 that divides 8 how many times? 4. So 2 times 4 gives us an 8. 4 here is not a prime number, so we have to continue the branches on it as well. So for 4, we have 2 times 2 again, which gives us 4. So we have 2 times 2. And with that, there's no other number we can continuously form branches on. We therefore take our 16. So for number 16, we continue with the same journey over here. The smallest prime number that can divide it is 2. And 2 times what gives us the 16. So it's a 2 times an 8. So I'll write my 8 over here. And since 2 is prime, we are not going to continue our branches on it, but then we continue on 8. So for 8, we have what? 2 times 4. And then for the 4, we have what? A 2 times 2. So in that case, if we want to write these numbers as product of prime, then it simply means that our 9 is equal to a 3 times 3. And we know 3 times 3 can be written as 3 squared. Our 8, on the other hand, is then written as 2 times 2 times a 2, which is then written in index notation as 2 to the power 3. Then our 16 can then be written as a 2 times 2 times 2 times 2. That is, we are multiplying those that I've written in what? Yellow. So that we have 2 to the power 1, 2, 3, 4, 2 to the power 4. So as you have been able to write their prime factorization, we then say our LCM. To get the LCM, we take all the prime numbers that are present. You see, so looking at our prime numbers that are present, there is 2 present, and then there's also 3 present as well. So with these ones, we then look for their highest powers. Their highest what? Powers. So taking 2, for instance, the highest power of 2 over here is what? 4, and not 3. So we take the highest power, which is 4. Then for 3, its only highest power is what? 2. So you put the 2 over here. Then we find the product of this. You see, we find the product of this. So it simply implies that our LCM that we want is what? 2 to the power 4 times 3 to the power 2. And we know 2 to the power 4 gives us a 16. So it's equal to 16 times 3 to the power 2, which gives us a 9. And if we multiply 16 by 9, we are going to get a 144. So it simply means that the LCM of 9, 8, and 16 is giving us what? 144. As simple as that. Now for this next question we have here, which is also a past question, It says you have to find the sum of all the factors of 24. You have to find the sum of all the factors of 24. And we said a factor divides a number without a remainder. You see, so whenever a factor divides a number, you are not going to get a remainder. So hence, we want all the factors of what 24, and then we find the sum. We'll add all together. You see, now in our tutorial lesson, we said there are so many ways you can get the factors. That is, if you know your multiplication table, you can easily get it as well. So for 24, let's look at the numbers that multiply each other to give us 24. We know a 1 times a 24 will give us what? 24. You see? Okay. We also know that a 2 times 12 would also give us a 24. And we also know that a 3 times an 8 also gives us a 24. Is there any number you know can multiply another to give us 24? You think we have not written? Yes, there is 4 times a 6, which also gives us 24. So to get all the factors of 24, then all of these ones, 1, 2, 3, 4, 6, 8, 12, and then 24. They are the factors of 24 because they multiply to give us what? 24. You see? Hence, we are going to write the set of factors of 24 is our 1, we have a 2, a 3, 4, 6, 8, 12, and then 24 itself. You see? So now the sum of all of them, and we know that sum means what? Addition. You see? So if sum means addition, then we want, if you want the sum of all of this one, it simply means that we are going to add 1 to 2, and then to 3, and then to 4, and then to 6, to 8, to 12, and to 24. And if you add all of this, you are going to get a 60, right? So we just say that therefore the sum of all the factors of 24 is what? 60. As simple as that. We have 2 more questions still under numbers and numerals, and then we'll be done. Now this question is just like the first one, which says you have to find the LCM of 3, 5, and then 9. Okay, so let's quickly look at how we are going to do that. Still on the method of prime factorization, we have to write all the numbers as product of their primes. Okay, so for 3, the product of its prime is just 3 because it's already a prime number. For 5, 5 is also still your 5. You see, then we come to the 9. So if you remember, we wrote out that of 9 over here. You see, so if you have forgotten, you can just write it and then practice that yourself. So 9 is 3 squared. So let's come back here and then write 3 squared. You see, then that means if you have to look at the prime numbers that are present, 3 is present and then 5 is also present. Now, if 3 is present, what is the highest power? This power is what? 1. The power here is also 2. So the highest power of the 3 is 2. Then we come to 5. Its highest power is just 1. So we take the 1. And then we do what? We multiply them. So it simply implies that our LCM is just 3 squared times 5. And we know 3 squared gives us a what? A 9. So we have 9 times 5, making what? 45. So the LCM of 3, 5, and 9 is what? 45. As simple as that. Let's look at our last question. Now, this last question is asking us to simplify 32 times 8 times 4 times 2, and we have to leave our answer in the form 2 to the power n. This is more related to what? Index notations. You see, so it's saying we should leave our answer to what? As 2 to the power n. That is, we have to write 32 as what? 2 to the power something, and we also have to write 8 to the power as 2 to the power something. You see, so for 32, 2 raised to the power what gives us what? 32. Now what this it simply means you are supposed to know all of this. That is 2 times 2 times 2 times 2 times 2. So you should know that 2 to the power 1 gives us what? A 2. Now if you have 2 of the 2's to the power 2 gives us what? A 4. 4 times 2 will then give you what? An 8. 8 times 2 will then give you a 16. 16 times 2 will then give you what? A 32. So it's 2 to the power, this is 1, 2, 3, 4, 5. So 2 to the power 5 gives us a 32. Then we come to 8. You see, we need 3 of the 2's. So 2 multiplies itself 3 times to give us an 8. 4 multiplies itself twice to give us an 8. And then 2 here is just what? Once. You see? So if you are able to write out your numbers as index notations, then to evaluate your 32 times 8 times 4 times 2, it is just going to be what? Our 32, which we know is 2 to the power 5, times our 8, which we know to be 2 to the power 3, times our 4, which is 2 to the power 2, and then times your 2, which is 2 to the power 1. The laws of indices say if you want to multiply out index notations and the bases, this is what we mean by the bases, they are all 2. So if all bases are the same, just write one of them. Then you add the index notation. That is 5 plus 2 plus, that is 5 plus 3 plus 2 and then plus 1. And that gives us what? A 2 raised to the power 11. So if we evaluate all of this and we want to write the answer as 2 to the power n, we are going to get 2 to the power 11, where n is equal to 11. As simple as that. So this is how far this video is going to get. I'll leave out some exercises that are just related to these that we have solved over here, just to test your understanding. So here the questions are that you can try on your own. They are just 5 questions. Okay. This is how beyond numbers where we learn maths the easy way. As I've said, the tutorial to everything that we have done here are on the playlist. You can visit them for insights and then understanding of everything step by step. If you have more questions and you want me to solve them for you, you can always put them at the comment section and then I'll address that when I see it. If this is your first time here, you can always choose to subscribe. That is if you so do wish, so that anytime I do anything related of this to this sort, you'll be notified as well. See you in our next lesson. Then bye for now.